Hello and welcome back to Mikey's Flightdeck. Today I will show you the build process of my fire panel section for my Boeing 737 pedestal. All the acrylic parts are prepared and cut out on the laser, and some holes had to be sunk first. At the beginning you will need 12 position rotary switches, 30mm female hex standoffs and the bottom plate. The rotary switches must be locked so that only the first 3 positions are available. Next, 3 pull switches will be needed and the corresponding acrylic plates. The middle holes of these pieces are slightly off-center, so watch out the orientation. You will find this arrow directly on my design files. This 3D printed part will prevent the handle from turning while it is in its normal position. It took me some attempts and I make different versions of thickness of these small cylinders here until I came out with a snug fit in this 3mm hole. I think when you build this, you have to model your own 2 cylinders. This won't be too complicated. These are just 2 cylinders concentric built on top of each other. And the size of the small cylinder that gets into the hole in the acrylic plate depends on the cutting width of your laser. In my case, this is 0.14 millimeters. This can be a different size on your machine. And so just model just a cylinder, try out how it fits in, and if it is too loose, then model it with a little bit wider cylinder on the bottom here. I have glued in my cylinders here, and I think this will hold them a little bit better in here. Now it's time to build in these 3 needles here. They will come on top of these rotary switches here, like so. It is a really snug fit here, and this is an advantage because we have to do something with them here. When you print these out, there is a 2.5mm pilot hole in there. And this is the size of the hole that we will need to cut in a thread. And we will use this pilot hole in addition to drill through this needle and drill into the shaft of the rotary switch. And after we have cut in the 3mm thread here, then we can drive a set screw through this needle, and because of the hole that goes a little bit into the shaft of the rotary switch, the set screw will go through the ring of the needle and into the shaft and lock it better in place than when it just sits on the outside of the shaft here. When you do this, you have to ensure that every rotary switch is in its middle position of the 3 available positions here.
Next I installed the 3 servo motors and glued the 3D printed ledge on top of the servo arms. With the backlighting mounted on it, this layer is secured with 30mm male hex standoffs. To build the main panel plate, you start with 2 big on-off-on switches. And 2 big momentary on-off-on switches. Then 4 push buttons. The color of the upper push button doesn't matter because it is covered later. The 3 layers are screwed together temporarily. Here you see again my workflow to build the needed annunciators. The building of the handle was really a long design process. My first version here came out too weak and broke down here, and so there followed a lot of different designs which all still were too weak and broke, until I finally came out with a design of the foot here that was stiff enough to hold the forces when I pull the handle. But then there were the next weak spots in the handle here, the outlet of the cables, and finally I came out with a final version which is stiff enough so that I can pull the handle without breaking it immediately. Instead of designing and producing a fancy PCB for the 3 LEDs that are settled in the handle, I will use these 5 by 7 centimeter breakout boards to make cutouts. And these are really cheap to get in a bulk and do a good job soldering in the LEDs and hold them in place. I have described this method in detail in my annunciator building video, and while I'm here making new PCBs, I can also make some more PCBs for the needed annunciators. Three red LEDs are soldered in a series connection.
One important optical spot of this panel are these red labels on top of the handles. This time I have used casted acrylic instead of extruded acrylic, which I used in most of the panels. I had this laying around already for a while. I have bought some smaller sheets of acrylic that I would need in the future in a bulk, and maybe there was only casted acrylic in this shop. It is a bit more expensive than the extruded acrylic, but the engraving comes out more wider than in the extruded acrylic. And so if you would like, you could leave the engraving already as it is here. There is one disadvantage in laser engraving, and this is that the surface that is engraved isn't really flat after the process. It is a rough structure with higher spots, and the white dust settles in the lower spots. And so when you backlight it, you will see the many high spots better than the lower one. So you come out with an uneven lighted engraving. This can be okay, I think. There is no need to change it here, but I think it can be better. And so I wanted to try out a new material, and this is this filling lacquer. Normally I'm using wax for filling engravings, but this is good for text engravings, but not for larger areas. Because when you clean the engraved surface, then you rub away some of the wax, and so you come out with thinner spots. And the theory behind this lacquer is that you bring it onto your engraved piece, rub it in and pull away all the wax that you don't need with a tool that don't hurt the material too much. Yeah, and then let it dry for a while and clean everything around this engraving. So let's see how this comes out. So after my first use of this lacquer, let's come to some thoughts about it here. First of all, the white looks very good. It comes out clear. It has hardened very good, and there won't be any scratches when you touch it. Yeah, I will apply a coat of clear varnish on top of it, and then it will be protected. It fills wider areas here, like the big numbers, definitely better than the wax. But is it as easy to use as the wax? No, definitely not. The lacquer hardens very fast, and it hardens even faster the thinner the coats are. And the thinnest coats are around the areas where you want to apply the lacquer. And so you can't wait too long until you start cleaning everything around these letters here. On the package is written that you should wait round about half an hour before you clean it, but I already started cleaning it 10 minutes after I applied it because it hardens so fast. Then you would have to rub very hard to get the lacquer away, and then you are running into trouble to destroy the lacquer inside the letters again. So I think this lacquer is made when you have really deep engravings and you rub it in, and it doesn't matter how hard you rub over your surface, there will be enough lacquer in the steep engravings. But here in my case, the engraving is not too deep here, and so I have to ensure that I don't rub into the letters here. So you have to take your time when you are cleaning the surface, and you have to be very exact and carefully when you do this. And this is definitely not a solution that you can use on a painted surface. For example, when you have painted a panel, engraved it, and then you think you could widen the letters with this wax seal. No, definitely not. You would destroy all your lacquer during the cleaning process. But now for this special purpose here, this came out really good. It will be visible very good in a dark cockpit, and I think this was a good solution now for this situation.
And if you ask yourself what this hole is for, this is to remove the label or the PCB if necessary. And here comes now the fact in very handy that I have decided to only screw this front box in front of the pedestal, because now I was able to unscrew it and disassemble it again, because now I know the exact dimensions and the way this fire panel sits inside of the pedestal box. So now I am able to mark and drill the holes that I need for the cross dowels, because I have decided again not to screw into this wood directly and mount the fire panel there, but using, like on my overhead and the rest of the pedestal panel, these cross dowels, so that I always can remove this panel when it is necessary. When you download the plans for the pedestal, I have updated them, so you will find the exact positions and dimensions of the holes in the plans.
The file for this 3D printed alignment jig is included in the plans for the pedestal.
And here it is, finally in place. Wow. Guys, I know I have said this sometimes before, but again, this was by far the biggest design challenge I had during all my panel making projects. There were so many functions I had to keep in mind and how to build them. Can I 3D print them? Will I make them out of some acrylic sheets and so on? But at the end, it came out absolutely beautiful. It's looking fantastic in this pedestal here, and I hope this will work for a long time in my cockpit. You don't have to invest as much time as I did, because you can download a full set of plans to cut out and engrave all the needed acrylic parts here, as well as files to cut out these improved PCBs here and the 3D print files for all the other 3D printed components. Like all my other files, you can find this in the member section of my website. And this is also another big step for the cockpit project, because my pedestal project is finally finished as far as I have planned it. There are still the 2 communication panels missing, but I have said before, I will build them when I find a way how to use them in a simulated cockpit. But for now, I would say this is finished now, and I can move on to the next section in the cockpit. And if you don't want to miss this upcoming episode, then subscribe to my channel to stay informed about any upcoming new video from me. And I hope we will see us soon back on the flight deck.